In this video, we're going to take a look at the semester review packet. I'm going to go through each page, and I've added some additional terms and questions that I'll go over through each page. Starting with the first page that goes over the undefined terms. Undefined terms are point, line, and plane. Here's how we name a point, name a line. Notice I also added that lowercase cursive letter, and we could name that line M as well. It could be any lowercase cursive letter. Naming a line segment. Notice the difference in the symbol, that it has no arrows, because that line segment is just talking about that piece of the line. We could also name that line segment BA. On the ray down here, we have two rays, ray A, B. Remember, we always name a ray starting with the end point and going in the direction of the other point. So this is ray BA because we're starting at B going towards A. To name a plane, we use three non-collinear points, or that uppercase cursive letter. I added that uppercase R so that we could name this plane R as well. At the bottom, we have segment addition and angle addition. Segment addition and angle addition means the parts add up to equal the whole. Whether you're dealing with segments or angles, the concept is still the same. I have two pieces that I'm adding together to equal the entire thing. So BC and AB add together to be AC. Here I have this part plus this part equals the entire curve angle CDA. On the next page, we have conditional statements. Just to remind you of a little symbol for negation is that little squiggle, and if and only if is the double arrow. P stands for the hypothesis, Q is the conclusion. We have the conditional statement, if P, then Q. I've written an example here. I want you to copy down. If two lines are perpendicular, then the lines form right angles. What I'd like you to do is use that statement to form the converse, inverse, and contrapositive. The converse switches. If Q, then P. The inverse is the negation of both the hypothesis and conclusion. If not P, then not Q. The contrapositive, if not Q, then not P. That switches and negates both. Then I also want you to write the biconditional statement. P, if and only if Q. We have a true biconditional when the original and the converse have the same truth value, whether they're both true or both false. Determine if that biconditional statement is a true biconditional. Also, another note, the contrapositive always has the same truth value as the conditional statement. So when you write your contrapositive, it will have the same truth value as that original statement. The next page is the theorem list for proofs, starting with algebraic operations like addition, subtraction, multiplication, and division. We have our reflexive property, where something is equal to itself. The symmetric property, where we can turn an equation around, A equals B and B equals A. The transitive property, where we have two things that are equal to the same thing, so those are equal to each other. If A equals B and B equals C, then A equals C. We have all the way through our segment and angle addition, which we've already covered. Our definitions, midpoint congruence, supplementary, complementary, perpendicular, bisectors of angles and segments. Vertical angle theorem and linear pair postulate. You need to know what those are. We also have our parallel lines and transversal theorems. Alternate interior angles, alternate exterior angles, same side interior, same side exterior, and corresponding angles. You also need to remember the converses of these that prove lines are parallel. So the converse, remember, is the switch of the hypothesis and conclusion. So remember we can prove lines parallel with those converse statements. We have the triangle sum theorem, exterior angle theorem, isosceles triangle theorem, or otherwise called the base angle theorem, and the right triangle corollary, which says the acute angles add up to 90 degrees. And then we have our triangle congruence and CPCTC. The next page has to do with distance and midpoint. I've plotted a couple of segments that I want you to practice on. The first is the segment with the points -5, 2 and +1, 6. And you can use the distance formula to find that that distance is 2√13. Remember, on the graph you could also use Pythagorean theorem to find the distance. Because distance is the length between those points, it's really just the length of the side of that right triangle that can be formed. So if we can count the legs of that right triangle, we can find its hypotenuse, which would be also 2√13. Notice using Pythagorean theorem, we got the exact same thing as we did using distance formula. And then using midpoint formula with those points -5, 2 and 1, 6, we're adding the x's and dividing by 2 and adding the y's and dividing by 2. And we get a midpoint of -2, 4. We can also use that right triangle to help us find the midpoint. We can find that vertical distance of 4 and take half of it and find halfway, because we know the midpoint is halfway along the segment. And we take that horizontal distance of 6 and cut that in half. And we can count from either endpoint vertically 2, which is half of 4, and horizontally 3, which is half of 6. So vertically 2, horizontally 3, and we end up at that midpoint -2, 4. Counting from that other endpoint, we could go horizontally 3, vertically 2. We still end up at that midpoint -2, 4. What I would like you guys to do is find the distance between the points and the midpoint of the segment with endpoints x at 0, -6 and y at 6, 3. Okay, looking at linear equations, we talked about slope a lot this semester, looking at the slopes of lines and how they're related. I've given you some examples on the graph here, and I'll talk about those in just a second. But I've given you the points in each one of those. For the slope of AB, which is down here, we have the points 3, -1, 4, -5. And using slope formula, I found that that slope is -4. The slope of CD, this line here, using that slope formula, I get the slope of a +1/4. The slope of OM, which is this vertical line here, we get an undefined slope. And the slope of YU, this horizontal line, we get a slope of 0. Remember HOI and VUX. HOI stands for horizontal line, has a 0 slope, and we have y equals equation. VUX stands for vertical line, undefined slope, and an x equals equation. What I want you guys to do is find the slope of the line containing the points 3, 2 and -3, -4. Looking at the graph, remember we can count our rise over run to find the slope. So I've done that for each of those sets of points. For CD, we notice it's a positive slope because it rises from left to right. We count our rise of 2, run of +8, and we get a slope of 1/4, which is exactly what we got when we used the formula. For AB, counting our rise of 4, but we're moving to the left 1, so that's a -1. So 4 over -1 is -4. Again, which is exactly the slope that we received when we did the formula. When we look at the vertical line, we're rising 5, but running 0. We're not going left or right. So that has an undefined slope. Here we're not rising at all, but we're running 5, so we have a 0 slope. Here we're going to go over how to find the equation of a line through a given point and slope, or when given 2 points. When given a point and a slope, the easiest formula to use is point-slope form. You can plug in m as your slope, and 2 is your y value, -7 is your x value, and then put that in your point-slope form. To convert that to slope-intercept form, distribute your 1/4 and then move that 2 over. And so this is your slope-intercept form, and this is what's called that vertex form or point-slope form. When given 2 points, you have to find the slope first, and then it turns into the problem that we just did. So given the points 3, 2, and -3, -4, find the slope of +1, and it doesn't matter which point you plug in because both of those points are on that line. So then plug in your point and slope and then find that equation. Remember, perpendicular lines have negative reciprocal slopes where they are the flip and opposite signs of one another. From the previous page, A, B, and C, D were perpendicular because -4 and +1/4 were negative reciprocals. And YU and MO were perpendicular because one was horizontal and one was vertical. I have 2 problems down here that I'd like you to work. Finding the equation of the line parallel and perpendicular to this line through the point -3, 4. Parallel lines and transversals. Remember, when we have parallel lines, we indicate that with arrows on our lines. So these are parallel. We know our corresponding angles will be congruent. When we have parallel lines, our alternate exterior angles are congruent. Also, our alternate interior angles will be congruent. Our consecutive exterior and interiors are going to be supplementary when our lines are parallel. Vertical angles and linear pairs will always have the same relationship because I don't have to have parallel lines in order to have vertical angles congruent and linear pairs be supplementary. I just need 2 lines intersecting in order to have that angle relationship. On the next page, we are talking about similar figures. I want you to first answer the question, what does it mean to be similar? That means that my sides are going to be proportional and that corresponding angles are going to be congruent. We can set up ratios of those corresponding sides and find a common scale factor. In this one, I've already given you a scale factor of 3, so what I'd like you to do is find those missing sides. We have 3 similarity theorems that make sure we would have similar triangles. These similarity theorems are side angle side similarity, where we have congruent angles and then those corresponding sides are proportional. SSS similarity, where all 3 sets of sides are proportional. And then angle similarity, where we have 2 sets of angles that are congruent, which means the sides will also be proportional. Next, we have our classifications of triangles: acute, right, obtuse, and equiangular. Our side classifications are equilateral, isosceles, and scalene. We have our triangle theorems, our angle sum theorem that says all of them are supposed to add to 180. The base angle theorem that says the base angles of an isosceles triangle are congruent. The exterior angle theorem that says the 2 remote interiors add together to give us that angle outside. And then the right triangle corollary, which says the 2 acute angles add to 90 degrees. Lastly, we have our congruent triangles. Remember, order matters for the corresponding parts. Make sure that your corresponding pieces match up. A corresponds to D, B corresponds to X, C corresponds to Z. Remember, CPCTC, corresponding parts of congruent triangles are congruent. So we have those corresponding sides that have equal measure and those corresponding angles that have equal measure. Then we have our 8 ways to show that 2 triangles are congruent. Make sure you understand the patterns for each one of these: SSS, SAS, AAS, and ASA, and then the 4 right triangle theorems.